Hello, everyone. Good afternoon. Happy Tuesday. We're kind of at the beginning of another week. We keep getting closer and closer to the end of the school year, but I did point out to my students earlier today that if we have 9 weeks in a quarter, we still have 4 weeks left. That is basically half the quarter. So we're only about halfway through. However, if you are of the senior variety, you have a little bit less than that. You have about 3 weeks left. So when I talk about the scope of the class, I'm really only going to be talking about those 3 weeks. And then once the seniors leave, we'll do a little bit more if you are of the non-senior variety. So just a few things to chat with you about today on my sticky note. First thing is that we have a test tomorrow. We have our triangle trig test tomorrow. This covers right triangle trig, so Pythagorean theorem, your SOHCAHTOA, cosecant, secant, cotangent. We talked about that a little bit yesterday. It's going to cover law of sines, so using your law of sines, determining the number of solutions of something, as well as your law of cosines. So that is, side, 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 angle, side, and things of that nature. So that is going to be the right triangle trig portion. And then there's also going to be an applications portion. That is story problems. Unfortunately, I can't give you an exact number of questions on the test because the test is still being written. We had a test as of this morning, and we were like, here's the triangle trig section, and here's the application section. And we kind of looked at it and we were like, this test feels too long for us. So what we're in the process of doing, both the other FAT teachers have planned during this period, so I think we're going to finish it up right now. Is we're going to take out some of the triangle trig questions and just kind of have the application questions count towards both targets. So because you're still using law of sines and law of cosines for those story problems, we're going to have that count towards the right the triangle trig stuff, but then the story problems will also count towards applications. So there will be some questions on the test at the end that do kind of count twice almost. But it means we can give you less questions. So we're kind of in the process of figuring that out. So if you hear some like dings going off, that's just me getting emails of them telling me, okay, well, I think we finished it, take a look. So I will have that finished by later today. So I cannot give you an exact number. I know as of right now, there's 27 questions on the test. I'm assuming there will be less afterwards. I think there'll be around 22 or 23. But we're also having like one question where you're finding like an angle, a side, and a side, like, something like that. That's 3 questions, not just one. So again, I cannot give you the exacts on the number of questions, but I know it will be less than it currently is. Also, I can say that we are giving you the equations for law of sine and law of cosine, but we're not giving you any context. So it's going to be up to you to know like what type of situation to use law of sines versus law of cosines, and also how to determine the number of solutions, 0 solutions, 1 solution, 2 solutions, that type of thing. And that's kind of what I want to go over today with you. But before I do that, are there any questions for me about the setup of the test tomorrow, the targets for the test tomorrow, anything like that? Okay, no questions. Just a reminder, other things we do have going on is our unit circle project. That unit circle project is due in 1 week from now. So it's due next Tuesday. We are going to be starting a new unit on Thursday talking about graphing trig, and it is related to that. So we're going to be taking a look at degrees and radians. That's the stuff with pi. And for your unit circle project, that's what I want you researching. I want you researching the coordinates, the degrees, the radians, why it's called the unit circle, how can I memorize this? And it's up to you to determine how you want to present that information to me. It could be in an informational video, it could be a TikTok compilation, it could be in some Google Slides, just as long as everything is explained clearly. And then I am going to need to see everyone complete a unit circle and have that memorized. That can be done in a video, or if you are present in the classroom, I can watch you do that. So it is kind of your choice of how you'd like to do that. But that is on the unit circle project. You are always welcome to ask me questions about the unit circle project. or if I can like maybe lead you in the right direction, I would be very happy to do so. And kind of maybe give you inspiration, kind of maybe what we're looking for in that type of thing. So remember that information can be found. Oh, that's not the page that we want. If I was to share my screen with you, if you were to head to Canvas and look under the Unit 9 project, or Unit 9 module, we have the Unit Circle project right here. Just a reminder, that's going into the communication target, and this is the only assignment that is going into the communication target. So please make sure you do this well. If you need to kind of check in with me, asking me like, kind of where is this right now? What grade would this be? Check in with me early and I can kind of tell you, oh, maybe you should show me more about this or explain more about this, and then maybe you can get a higher grade. So if you want to check in with me like that, you can. But all that research is there. So before I start getting into reviewing with you just a little bit for today, did we think of any new questions about that Unit Circle project? Whole class questions? Okay, I don't see any from the class. I do see something in the chat. No. So someone in the chat is asking, like specifically about the grading of the project, is asking, are we graded on the memorization of the Unit Circle or the project itself? The answer to that is both. So if we go and we take a look at the rubric that we have set up for the Unit Circle project, you'll notice that the last bullet point for each of these is about the memorization of the Unit Circle. So in order to just earn a 2 overall, you have to at least have the degrees and the ordered pairs. We find that radians tend to be the trickiest for people. That's why it's like, if you can get at least 2 out of those 3 things, we'll give you a 2 overall. 3 is you have to have most of that Unit Circle memorized. And then 4 is like, you basically have this memorized. Maybe you miss like a negative somewhere, right? That's like one really small mistake. So that is part of the rubric. So the first 2 pieces are about like the research and how you're presenting it. And then that last piece is about the Unit Circle. So I will be grading you on a combination of both. Other questions about Unit Circle project? Okay. This is under today's date as well, because you can spend today either working on this project if you like, or reviewing. So I will spend the next, I don't know, 15, maybe 20 minutes, just reviewing some like general overview of law of sines and law of cosines, just to make sure we see that right before the test. And then afterwards, I can either go over any questions from the review, any topics, or anything from previous GoFormatives, or we can talk about the Unit Circle. I'm happy to work on with whatever you'd like to work on today. Just know that I did leave you some resources down here, just everything I left from my pre-calculus class. I'm like, here's some things, these are all available on YouTube, so you may have found these anyway, but this is just me personally going through degrees, radians, and the coordinates or the ordered pairs. And then down here are some games that you can play in order to practice your memorization. So if that's what you want to do today, you're like, I just want to do some like matching games. That honestly, that is homework for you. That sounds perfect. So that can be found down here. Unit 7 retake was yesterday, but then we have our test tomorrow. And this is from yesterday's class recording. I'll make another one down here. So tomorrow after you have your test, you will have a video and some notes to take for Thursday's material, so please make sure you do so. That material can be found, where did it go? There we go. I haven't made the page for it yet, but the test will be found at the bottom of the Unit 8 module, because it's the Unit 8 tests for the triangle trig. So that will be found down here. If you'd like to specifically look at the review information, this is from last Friday. We're still just working on the same review. It's a pretty big review. But make sure that you also look at the other GoFormatives. They're fairly long as well. But like I said, I'm not going to go over any specific problems at the moment. I just kind of want to go over like general topics. Here's how we figure things out. So I'm going to use things fairly broadly, but later on, if you're like, I want to go over problem number 7 from this GoFormative, we can absolutely do that. So I'm going to stop sharing this screen with you. I always forget it doesn't bounce back. Okay. And I just want to talk about law of sines and law of cosines, kind of some general things you're going to need to know for the test tomorrow. And then afterwards, you are able to work on whatever you would like to work on, and I can answer any questions you may have for me. So I'm going to share my screen with you. This one. If it would like to pop up. There we go. Oh, sorry, that's my pre-calc class. Okay, so everything I go over with you right now is not new information. So if you just want to watch, that is okay. It's very similar to the information on page 1 from the review answer key. On the first page of the review answer key, I just kind of like say a lot of general things. This is very similar, but if you'd like to write it down, feel free to follow along. So first thing I'm actually going to talk about is law of cosines, just because this one's going to go just a little bit faster. So for law of cosines, we're going to use that in 2 situations. We use law of cosines for side, side, side. So that's when I give you all 3 side lengths. And we're also going to use it for side angle side. That's when the 2 sides make up the angle that I'm giving you. So if that angle's in the middle, that's going to be a law of cosines problem. For both of these problems, or for both of these situations, it's always just going to be one solution. Law of cosines, it's a one solution. So if you're on a test, if you were asked how many solutions is this, how would you know? You might say, well, it's law of cosines, so it's one solution. That's enough. That's all I'm going to need from you. Now, our equations for law of cosine is the first one we think of c squared is equal to a squared plus b squared minus 2ab cosine of c. Now, like I said, you will be given this equation tomorrow on the test, but your triangles may not always have a, b, and c. Maybe it's d, e, and f, right? Like maybe it's different letters. So just keep in mind that whatever side length you have over here, you have the matching angle over here. Those should always be the same. And again, anything that is lowercase is a side length, and then uppercase or anything in there, that's going to be our angle. The last kind of piece is if you are dealing with a side, side, side situation, and you're like, I don't know which side or which angle to solve for first. Always solve for largest angle first. Well, how do we know which one is the largest angle? Well, largest angle is always across from largest side. So for instance, if your side B was the largest side, then you're going to want to start by solving for angle B first, since it's going to be across from that angle. Now, when you're dealing with law of cosines, you can certainly use this equation 3 times in a row to solve for your various angles or side lengths. However, that kind of seems like a lot. I don't know about you, but I can do law of sines much faster than that. So when we've practiced these problems in class together, first thing we always did was use law of cosines. Secondly, we used our law of sines to find our next piece of information. And then no matter whether we started with side, 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 or side angle side, we always had an angle left. So at the very end, we could just do 180 minus our 2 angles to get our last one that we need to know. Every single time, no matter what situation you're starting with, that's all you need to do. And I think that's kind of all the big information we need to know about law of cosines. So again, I haven't actually gone through any problems yet, but this is kind of the big stuff that we need to know. So before we take a look at law of sines, which is a little more interesting because of the ambiguous case, are there any questions for me about law of cosines? There goes our other two FAT teachers. You want to come say hi? Come on. They're both embarrassed. Okay, well, I guess that's not happening. Bye. That's Ms. Schaffner, Mr. Doherty. They were just working on the test. So, questions about law of cosines? Don't see any here. Don't see. Okay, so like I said, law of sines is a little bit more interesting. Not because the equation itself is actually not too bad. It's because of the number of solutions. So let's take a look into that. I'm going to scroll up. If you ever need me to scroll back down, I can. Let's take a look at law of sines. So law of sines, that's 3 different situations where we might have law of sines. We have angle, side angle, where we have 2 angles with a side in the middle. We might have angle, angle, side. We have 2 angles and a side on the outside. And then we might have side, side angle. So whenever we have 2 angles, no matter what, always one solution. So if I was to ask, how many solutions does this triangle have? How do you know? You might say, oh, well, this is an angle, angle, side triangle. So there's only going to be one solution. So that works. But if it's side, side angle, that's when things get really interesting. So before we get into that, I realized I didn't even write down the law of sines. So the law of sines itself, let's write it down in purple. I'll do it off to the side. Actually, you know what? We'll do this. Writing down law of sines. Right here, I'll write the equation. So I always do my angles on top. If you have it flipped, that's totally fine. So we'll have sine of A over side A is equal to sine of B over side B, which is equal to sine of C over side C. Again, if you prefer to have like side length C over sine of C, that's totally okay as long as you're consistent all the way through. So this is what we have here. So we got here. These we just solve like normal, kind of solve however you want to start. But here, this is the ambiguous case. So there's so many different types of solutions. We have to figure out how do we determine this. Well, there's kind of 2 different situations. Either that one angle you're given is bigger than 90 degrees, or it's smaller than 90 degrees. Because if it is 90 degrees, we can just use like our SOHCAHTOA and things we talked about yesterday. So let's look at that first situation. So that first situation is when the angle is bigger than 90 degrees, right? So if the angle is bigger than 90 degrees, it's either a no solution or a one solution. So a no solution might look something like this. For these next two situations, I will give you some like exact numbers, but I won't be able to for the next 3. So let's say I have, so my angle is bigger than 90 degrees. Let's say it's 100 degrees. Sure, why not, whatever. Let's say the side length over here is 3. Let's say the side length over here is 7. Well, we've already determined that the largest side has to be across from the largest angle. So this 100 is across from 3. Well, 7, that's a larger side, right? So that means that this angle has to be larger. So it has to be at least like 101 degrees or something like that. Now, does this make sense for a triangle? No, because this is 100, this is 101. A triangle is only supposed to have 180 degrees, right? This is way too big. So for this one, we can say this is a no solution because largest side is not across largest angle, right? So that's going to tell me right away because this angle is over 90 degrees, which means the other two have to be smaller than 90 degrees, right? That's the kind of the obtuse, acute way of it. Whereas if we were to flip that around for our one solution, oh, I halfway did capitals, halfway didn't. If we were to switch those sides around, ooh, it's a very not straight triangle. Okay, so you have 100 degrees. We'll have that across from side length 7, and here's a 3. Okay, well, I look at this and I go, okay, well, 7's larger than 3. It's across from my largest angle. Okay, I'm good. All right then. So this one, it's a one solution. Largest side is across, I should probably say from, that is proper English, across from largest angle. And then we would just solve like normal. If it's a one solution, I'm going to have you solve. If it's a no solution, there is nothing for you to solve. Now, if you didn't notice that this was a no solution right away and you did start to solve and started to do your thing, you're going to end up with a domain error. Or your calculator might say math error or something. It's an error in some way because there is no solution, so there is no answer. So while you're working on the test tomorrow, if you come across a no solution and you're like, my calculator's doing something wrong, I don't know what I did, it's telling you it's a no solution. You didn't do anything wrong, okay? But this is the situation for side-side angle when the angle is greater than 90 degrees. So are there any questions for me about what we talked about so far with law of sines or about when the angle is larger than 90 degrees? Yeah, feel free to take a picture. Because it gets real exciting when we talk about, well, what if the angle is less than 90 degrees? That's our other situation. In this one, you're going to have 3 situations, either 0, 1, or 2 solutions. So someone is asking a question. So there cannot be 2 solutions. When the angle is greater than 90 degrees, there's either 0 or 1. That's it. But if the angle is less than 90 degrees, it's possible to have a 2 solution. So that's kind of where things get a little iffy. So let's take a look. So if we have a no solution, the triangle might look something like this. So first thing we're always going to do is we're going to look for that height. We need to compare one of your sides to the height. So I'm not going to give any numbers because for this type of situation, it's really hard to come up with numbers off the top of your head. So I'm just going to say that you're given this angle here, this side here, and this side here. So that's my side-side angle. Well, I want to compare this side here to the height. Now, the way to find your height is it's always going to be your adjacent side, stop it, there we go, times sine of your angle. So in this case, when I'm talking about opposite and adjacent, I'm talking about in terms of the angle that you're given. So since I'm given angle A, side length A would be my opposite side because it's on the opposite side of the triangle. And side B would be my adjacent side because it's next to or attached to that angle. So to find the height, I would do B times sine of this angle A, or whatever letters you're given. And I'm going to say, hey, you know what? This opposite side right here, that's too short to like even connect, right? It's kind of like giving this little dangle at the end. So if this opposite side is shorter or smaller than that height, it's not even going to connect. It's not going to work for us. So it's a no solution if that side is less than your height, or we might just say generally if that opposite side is less than the height, it's a no solution. It just doesn't even connect, not going to work for us. And again, the same thing. If you don't notice this right away and you start to solve, you're going to end up with a domain error. And so you're not doing anything wrong. It just means it's a no solution. So that means that if we are able to get that other side, so like if this is my opposite side, it's not even connecting. But if we are able to get it to connect, you have at least some type of triangle. But it's like, well, do we have one solution or two solutions? So our one solution might look something like this, where we give you, again, this side A, this B, and this A. So first thing I'm going to check for is that height. And I'm like, okay, this opposite side, it's like way longer than my height, right? Okay, I know it connects. We've at least made a triangle. So again, this is the opposite side, the adjacent side. So the first thing that I check for is to see, okay, that opposite side, yeah, that's bigger than my height. It connects, all right? So that opposite side is bigger than the height. But now I need to compare this side A to this side B, or my opposite side to my adjacent side. Now we're going to cross our fingers that what I do next works, because sometimes it doesn't. There we go. Okay. Okay, so if I take that side A and I swing it around, it never reconnects with my triangle. There's no other type of solution I can make. So this opposite side is so much longer than this adjacent side that it never reconnects to the triangle. So that's the second thing that I check for. If that opposite side is greater than that adjacent side, it's a one solution. So again, check for that opposite side is greater than the adjacent side. I'm listing the letters here for this specific example, but I always like to think about that because that kind of tells me more generally what to do. So this is an example of a one solution. But what if this opposite side is shorter, right? What does that look like? So for the two solution, I'm gonna flip around my triangle. That's a weird looking triangle. All right. So we've got this angle, these two sides. This side A, that's my opposite side. Side B, that's my adjacent side. Again, first thing I'm going to do is I'm going to check for that height. If this opposite side is larger than the height, we have at least some type of triangle. So we're going to check that it's greater than the height. So that gives us at least something. But if we take this side length A and kind of swing it around like we did before, hey, that reconnects with my triangle, right? It swung around again. So here's a new side length A. So I have that triangle outlined in black that has this angle A, this side B, and this side length A. We also have this one right here that has this angle A, this side length B, and the side length A. It takes all three pieces of our given information and makes a whole new triangle with it, with the same information. So this is our second triangle, and it's because this side length A kind of like came back around. It was too short to go past it. So if that side A is less than that side B, or if your opposite side is less than that adjacent side, that's what makes it a 2 solution, because it swings back around into the triangle. Now, this is something I will have you identify, but we never talked about solving for a 2 solution, so I wouldn't have you do that. And that was a lot of me talking, so I'm going to pause again. I'm going to zoom out a little bit so we can see. Are there any questions for me about law of sines or about when it's an ambiguous case and the angle is less than 90 degrees? Okay. So this is kind of, again, the big overarching thing. I haven't actually solved for anything in any of these problems yet. So if you want to practice like actually using the law of sines or using the law of cosines, I would be more than happy to do that with you. But I thought it would be beneficial to go over all the different scenarios. Again, when we have the angle is greater than 90 degrees, you don't have to look for the height. You don't have to do that, right? You only need it if the angle is less than 90 degrees. If you have the situation of angle side angle or angle angle side, even though it's law of sines, those are just one solution. They're not the ambiguous case. You don't have to do any of this extra stuff. You only have to do the extra stuff if you have side side angle. Again, most of this information is on the first page of the answer key to the review. So if you didn't write any of this down, you can most certainly take a picture or you can look there as well. But I know that yesterday we spent time on right triangles, so I want to make sure we spent some time today with law of sines and law of cosines. So that's all I have planned for us today. Feel free to stick around if you want to work on your unit circle project, or if you want to ask me more questions about the review. Just know that tomorrow you have your test. It's open from 8 a.m. to 11:55 p.m. And to make sure to watch tomorrow's video as well, so that you can be ready for Thursday. So stick around. Otherwise, I will see you on Thursday. Goodbye, everyone. Thank you. I'm going to pause this recording.